This lesson is about chemical bonding. The learning target is to be able to identify compounds as ionic or covalent. So let's first talk about what a chemical bond is. A chemical bond is a strong force of attraction holding atoms together in a molecular crystal resulting from the sharing or transfer of electrons. Again, it's all because of the electrons and what those electrons are doing that causes our chemical bonding and our chemical reactions. And it all comes from this idea that if I have a positive charge and a negative charge, those two things are attracted to each other. There's a strong force of attraction. And so remember that my positive charge in my atoms comes from my protons, which are found in the nucleus of the atom. And my negative charge comes from my electrons, which are found around the outside of the atom in a bunch of empty space, really small subatomic particles that are on the outside of the atom around the outside. Let's think about if I have a bunch of positive charges in here. Let's say this is my nucleus. I've got some protons in there, and I've got, again, we showed sometimes our electrons looking like this, but what's really going on is they're not really in this neat orderly fashion. Let's say we had a couple more in here. Let's say we had, I don't know, those electrons right there. What's really going on here is these electrons aren't just, traveling around in a perfect circle. What they're really occupying is something called the electron cloud. And that means that they could be really anywhere in this space around the atom. And so I could have an electron, instead of having it in this circle here, I could have it right here. That electron could be here. It could possibly be out here. It could possibly be way out here. It's most likely to be around in this area, in that outside ring. Those electrons really can flow anywhere. And again, they're attracted to the nucleus of the atom because of those positive charges there. Now, if I've got another atom out here, let's say I've got another nucleus with some positive charges in it, and I've got some electrons floating out here. Actually, you know what, this time, I'm just going to draw the electron cloud. So again, the rings are a way of showing the different energy levels. Let's say this one, got our electron cloud out here. And so our electrons can really be in any space around this atom. They're just more likely to be in certain spaces of the atom. Now let's say we had an electron right here, a little negative guy. And maybe we've got another one over here, right? Maybe we've got another one over here. Now this electron is, again, attracted to my nucleus here. This electron is attracted to the nucleus here. And so what I'm trying to show here is that there's a lot of different interactions going on here. So let's say that my electron, this guy right here, ends up finding his way out to here. He's still attracted to the nucleus because there's positive charges in there, but he's also attracted to this other nucleus because there's positive charges over here as well. And so he's got a little bit of a pull over to this other atom. And so because of that, this nucleus has a little bit of pull towards that electron because, again, this is a negative charge. We've got positive charges over here. And so what's going on in a chemical bond, in at least a covalent bond where these electrons are being shared, and it's kind of a blurry line between covalent and ionic bonds, we won't get into that very much, is what happens here is you get more electrons finding their way into the space between the two atoms instead of around their own atom. And when you get more electrons finding their way in between the two atoms, what you end up getting is the atoms being pulled together. The atoms are being pulled, the nucleus are being pulled towards the electrons, which are found in the middle between the two atoms, and the electrons are being pulled, towards the different atoms in between the two atoms because we have our nuclei here. It's kind of a rough understanding of what's going on here, but essentially it's because the electrons are being shared, moved, transferred between those two atoms, and all because of these attractions between electrons and protons. So if you remember our noble gases, you remember that the noble gases, I briefly touched on it, is that the noble gases are stable. I did not say this, I don't think. It's because of the number of electrons in their outer ring. The noble gases actually have a full outer ring. They aren't going to be trying to gain and losing electrons. That's what this whole chemical bonding comes down to, is whether the atoms are going to be gaining or losing electrons, whether that's through sharing or transferring. But our noble gases have a full outer shell of electrons. And one thing to note is that our outer shell will hold 2 for helium, but for these other ones, our outer shell will hold 8 electrons. So that's something called the octet rule, that atoms are going to be gaining or losing electrons until they can have a full octet, or a full outer shell, having 8 electrons in that outer shell. So that's what we'll be looking at in the next slide. So because of this octet rule saying that our atoms are trying to find a full outer shell, most of the time they're trying to get 8. With hydrogen, trying to get 2, but most of the time they're trying to get 8. You can see that our fluorine, on its valence electrons, its far outer shell of electrons, it has 1, 2, 3, 4, 5, 6, 7. Same with both of them. So our fluorines are each trying to get 8. So one fluorine is trying to gain 1, and the other one is also trying to gain 1. So what they decide to do is they decide to share their electron that is not paired up here. And this forms a covalent bond, I guess. This is formed by the sharing of electrons between our 2 nonmetals here. And so once they both have their full outer shell, they're both surrounded by 8 electrons, and they are both happy and stable here. And so this is the same type of thing that happens with a lot of these nonmetals, is that one electron, or one atom, will give up an electron, and the other atom will also give up an electron, and they'll form an electron pair, and that is what will bring those 2 atoms together. But the things you need to remember here is that covalent bonds are formed by the sharing of electrons, and this happens between nonmetals only with our bonding here. And so if I look at my periodic table, if I ever have 2 atoms like H2O, those are both nonmetals, and so that is a covalent bond. Those electrons are being shared between those atoms. If I had something like, let's see, F, well, I can have HF. That would be another covalent bond. I could also have something like CF, CF4. Well, that has my carbon, which is a nonmetal, and I've also got my fluorine, which is a nonmetal. So this is a covalent compound. And so that's how your periodic table is important, to know where the nonmetals and the metals are on there, so you can decide if a compound is an ionic or a covalent compound. So our next type of bond is called an ionic bond, and this is the electrical force of attraction between oppositely charged ions. And remember that ions means an atom has lost or gained electron. This means the electron has completely left an atom and found another atom, I guess, to be used by. And this is, and the words that I'd like you to remember for this is formed by the transfer of electrons. These electrons are actually moving between metals and nonmetals. It comes because these nonmetals are really something called electronegative. They want to hold these electrons very tightly, and our metals are more comfortable to give up those electrons. So they'll just thought about sharing, but then they just end up giving them away. And so this electron would leave, go to chlorine. And now if chlorine has the same number of protons, gained an electron, now chlorine has a net negative charge. And if sodium has the same number of protons that it had before, the same number of positive charges, but lost a negative charge, now it has a net positive charge. And so a positive, this atom, this ion, is positive overall. This ion is negative overall, and the same thing happens that would happen with an electron and a proton. We have opposites that are attracted to each other, and so we have our ions forming ionic compounds because of the transfer of electrons. Big words to remember. It comes from transfer, and it happens between metals and nonmetals. And so if I had a compound like NaCl, well, my Na is a metal. It's over on the left-hand side of my periodic table. And I have my chlorine, which is a covalent or not a covalent compound, it's a non-metal. It's on the right-hand side. And so this would be an ionic compound. I could also have something like, let's see here, aluminum. Well, I could have aluminum chloride. Right? My aluminum is a metal. My chlorine, again, is a non-metal. This would be an ionic compound. I could even have something coming from my transition metals. I could have copper chloride. This would be my copper, my chloride, ionic compound. And so that's where your ionic compounds can be recognized through your periodic table, or understanding when you have a metal paired up with a non-metal, you know that's an ionic compound. The electrons are again being transferred from one atom to the other. So I hope this video has helped you to understand the difference between ionic and covalent compounds. Ionic being between a metal and a nonmetal, and because the electrons are transferred, and then covalent being between two nonmetals because the electrons are being shared. And so if you want to, at the end of this video, go ahead and pause it and practice deciding and using your periodic table to figure out if these compounds are ionic or covalent. But I hope this video helped.